Hello, everyone, and welcome to the IEEE webinar series. Today we have a very interesting webinar named called the Contextual World and You, and it's actually a joint webinar presented by IEEE Young Professionals and IEEEmadC, and we're going to have a short introduction on what IEEEmadC actually is. But first, I'm going to give an actual introduction to the webinar itself and IEEE Young Professionals. So today's webinar is actually presented by Faisal Abid. And welcome to the IEEE Young Professional Series. My name is Matthew Carius, and I'm the host of this webinar today. I'm currently the Vice Chair of Communications and Marketing for the IEEE Young Professionals Global Committee. And if you haven't already known, we're going to be hosting monthly webinars continuing on in 2015 and 2016 on effective communication, leadership, and many and selected technical topics as well. In terms of what you, the audience, can do to participate in this webinar, you can actually type questions during the webinar in the question box below on our IEEE TV Live page. You can also upvote for questions throughout either of the talks, the MADC talk or the actual webinar today, and all questions will be answered following the webinar in a 5 to 10 minute Q&A session. Please connect with young professionals online. We have two excellent career-based services. I'm going to talk more of those at the end of the webinar today, but please follow us, connect with us online, Facebook, Twitter, LinkedIn. We are actually very active on all these channels, especially our YouTube channels, where we have almost 100 videos of cool tech snippets all around the world. And without further ado, I'm going to introduce our speaker today, Faisal Abid, and IEEEmadC. Luca from IEEEmadC will be giving an introduction. But before that, in this short webinar by Faisal, he will learn about different types of sensors that exist on our devices and how you can take advantage of their APIs. But first, a quick introduction on IEEEmadC. Luca, if you could give us an introduction on what IEEEmadC is, that'll be great. Thanks for joining us.
Thank you, Matthew, and thank you for bringing us into this awesome webcast. So, my name is Luca, and I am currently the chair of IEEEmadC competition, and in the next couple of minutes I would like to introduce all of you guys and girls to what IEEEmadC actually is and what and why are we doing with it. So, actually, what does the IEEEmadC abbreviation means? And as you can probably guess, it's nothing of this. It's actually IEEEmadC is Mobile Application Development Contest. So MADC is a pretty new contest which is designed for IEEE students only, similar to IEEE Extreme, of which probably most of you have heard about. So basically, how MADC started? Well, there was Josip Balen from Croatia, who is founder of MADC, and he got this awesome idea of creating a new competition for IEEE students to compete on, inspired by, of course, IEEE Extreme. And well, that's about it. He assembled a team in which one of the members I am, and we also have Igor and Dinko. Dinko is our design and sponsors coordinator. Igor is technical guy, and I'm coordinating all of the team and contestant parts. So actually, well, I didn't actually got to the part where I tell you what MADC exactly is, so I just kind of skipped that part. So MADC is a competition on which students apply, and IEEE students apply, and it contains two phases actually. It contains idea phase and application submission phase. In the idea phase, the students submit their ideas of what kind of mobile application would they like to build. Of course, the specific thing for IEEEmadC competition is that the ideas and the thematics of mobile applications have to be related to IEEE or to the IEEE causes, and the main cause is creating technology to benefit humanity, right? So that's the specific thing about MATC. In 2013, we started the competition and went only for the region 8, which is Europe, Middle East, Africa, and with Russia, of course. We had 82 idea submissions and 165 participants. Out of those 82 ideas, we had more than 30 working applications, which were submitted in the last phase of the competition. And we actually reached more than 60,000 people on Facebook. Here are some of the prizes that were given in the first year of the competition. So basically, we had four main categories of awarding contestants, and there was a best team category, or actually best application, best design category, and popularity category, which we awarded to students which had most likes for their application. And of course, with the help of our sponsors from Computer Society, we also awarded an Apple iPad. Here are some of the teams that won on the first iteration of MATC, and basically the best design award went to a Croatian team which created an application for automated exam evaluation, which had pretty neat OCR capabilities and could be used in classrooms for taking exams. The Computer Society special prize went to WikiAni team from Ireland, who developed OCR application for recognizing items in a picture and then delivering the description of what an item is. The team winner award went to my IEEE team from Milan, who built the mobile interface for the My IEEE portal. And the guys actually used various HTML scrapers and so on to adjust the application for mobile interface. And the highest popularity award went to IEEE Helwan application, who built the application student branch, who built the application for their local student branch. And we, of course, didn't want to stop on Region 8 only, so in the October of 2014, we started the competition for all 10 IEEE regions. And here are some of the awards that we are giving out this year. Unfortunately, the idea submission is already over. It was over on the 28th of February, and we are today coming to an end of the application submission period as well. So the deadline to submit the working applications to MATC is in 2 days, actually, and we are looking forward to see all the awesome applications. We had more than 130 ideas accepted into the competition. And this year we also decided to boost up the awards a little bit. So for the team winner award we have $4,000 prize. For the best design we have 2, highest popularity 1,000, and Computer Society has again generously awarded us, given us an iPad to give to best application coming from IEEE Computer Society members. And that's about it for my short introduction of MATC. And we are welcoming all of you guys actually to contact us and to help us if you think this is something that you might be interested in. And you can reach out to us on our website through the contact form or at Facebook, and you can find our Facebook page with the same name as the competition. And yeah, that's all that I wanted to present. So thank you for your time, and if you have any questions you can put them up straight here or contact us on our Facebook page. And now I'm just gonna leave the stage to Faisal.
Thank you, Luca. Hi everyone, this is Faisal, and my presentation is about the contextual world and you. So, when I started, when I had, once they told me I had to present, I started thinking about what topic to talk about, and one of the topics I'm really passionate about is context and the mobile world. Because we have all these sensors and everything on us, we can develop some pretty killer application. So this presentation hopefully is going to let you get inspired, and in the next competition next year, maybe build something that helps people out, and contextual apps are the best way. So about me a little, I'm an entrepreneur. Currently, I'm at Lead. We're a health startup in Toronto. Previously, I was at Kobo. I'm also a Google developer expert, so if you have any questions around Dart or even Android, I'm willing to help. I love Android, I love Dart, Node.js, and I love contextual apps. So what are contextual apps, right? Contextual apps are the ability to respond to the context in a given situation. But what does that mean? Do you know of an example? And I think an example that's touched all of us is advertising. And like targeted advertising, if you were to go to something like DigitalOcean.com, browse a bit there, and look at what DigitalOcean does. And DigitalOcean is a service provider like AWS for hosting your applications. And then go to YouTube.com after, and just search for any video related to technology, right? Maybe even search for IEEE webinar video. The advertising you'll see before that video almost guaranteed is going to be, right? And you'll see it over and over again, like especially if you're using DigitalOcean day in and day out like me, you'll start hating this ad because it's the same thing over and over again. It's not necessarily a really smart contextual application of advertising, but it works and it pushes the brand in your face. Oh, no one loves advertising. So what happens is you go there and YouTube goes to their server and passes a secret session ID cookie that's hidden on your browser. The YouTube servers go, hey, I know about this cookie. DigitalOcean, this same cookie was seen on DigitalOcean just a minute ago, and DigitalOcean is paying us all this money to show an ad, so let's show this ad. And it happens instantaneously, and it's really fast. And in reality, it's actually a great way to get your brand out there. But that's just one use case of it. What's another great use case, right? So, for sure there are other better use cases. So this is a kind of a dumb example, but can get your creative juices flowing. Basically, imagine you take all the data out there. Right now you're a student, so imagine you take all the data out there, and you're like, all right, I want to build a really, really smart exam calculator. Now, what does that mean? That means that this exam calculator should be able to know when your exam is, know what type of exam it is, and surface the right areas, and even maybe modify your phone a little, the settings on your phone a little, such that your mom doesn't call you in the middle of an exam and you get caught for cheating, right? So imagine you have a calculator and it knows you connect it to your calendar, and it knows somehow that you have an exam at 2 p.m. So then at 2 p.m. you walk into your exam room, and automatically the calculator app pulls up. It's a math exam, so automatically the calculator app pulls up, and it pulls up the right functions. So I don't imagine you're doing some derivative stuff. There's some derivative style calculations there. And then it goes into full screen mode, and it puts your app into airplane mode. All that stuff, that's contextual. That's a really smart contextual app. You didn't have to do anything. It pretty much read your mind. And I think that's the best way to describe a contextual app is basically we're all becoming magicians, and we have to read what's on the user's mind using all the crazy information we have. Is it useful? Not really. Maybe not. I mean, maybe it is, and maybe you'll make this for your next hackathon. But I don't know. I wouldn't find it particularly useful. However, the actual development part, where you're taking all the different pieces of contextual data, sticking it together, is kind of useful. Imagine instead of an exam app, you had a crib note app, right? So you write all your notes about a physics exam, and it knows when your physics exam is, and maybe even it does something smart like go and fetch related information about this topic and stick it in your crib note because on a you're given a piece of paper, but now imagine it's an piece of paper and you have all the information. It goes and it adds all the related information you need for your exam, sticks it right in automatically. Then when you get your exam, you step in that room and it knows that you're in that room and it goes, hey, here's your crib note app with all your cheat notes for your exam, and you're good to go. So that's what you have to start thinking. We have all this data. You have to put good use for it. So to recap, a contextual app is you take advantage of the data given to you and show it the right information at the right time. Now, connecting to APIs is one thing. Connecting to your calendar is one thing. Reading some metadata from your calendar is another thing. But the one key thing that we're all carrying around, like essentially like a third limb. Like before, 20 years ago, we had a set number of limbs. 20 years later, we have one extra one, which is a mobile phone. So let's see what type of sensors. Actually, why do we even care about sensors? It's because sensors provide instantaneous data, personalized and unique to a specific person. The sensors on my phone are going to uniquely report something about me, and it's going to be completely different from someone else, right? So what type of sensors exist right now? A proximity sensor. So this is on an iPhone. A proximity sensor. So how close a phone is to your face, or even anything else, right? You got to start thinking outside the box. A motion and accelerometer, so you can tilt left and right, how fast you're moving. So usually this is used in games. It's also used in a really cool application we'll get to in a bit. Ambient light sensor, is it night, is it day? This is actually used when you're, when you have your display set to automatic brightness to save battery life. It knows, hey, it's outside, I don't need tons of battery life. It'll turn the battery screen brightness down. If it knows you're inside, it'll turn the screen brightness up, or vice versa, actually. There's also on iPhone a moisture sensor. There's no real API for it. It's actually like a hardware-based thing. I just thought it'd be cool because I discovered it. If your iPhone falls in the water, there's actually the sensor turns blue or red, some slight different color, and it knows that it fell in the water. There's a gyroscope, which is a rotation 3D space sensor, and this tells your phone which axis it's on. And lastly, there's a compass so you don't get lost in the woods. And I remember when mobile phones first came out, every person and their mom built a compass app, and iPhone introduced a fingerprint sensor, and that obviously we all saw it's pretty cool. You hit your thumb or choose 5 fingers and you're good to go. Over on, and that's a link at the bottom, and you'll be able to get more information about all the sensors out there. On Android, you have a bit more sensors. Most of them are the same. You have a proximity motion sensor, you have an ambient light sensor, but then some phones on Android have an air pressure sensor. That's kind of cool, and we'll get to an application of that shortly. You also have a magnetic field sensor, and this sensor, I believe, is on most of the Android phones. I remember when Android first came out, they had the T-Mobile G1 phone, and one of the first apps on the Play Store was a magnetic sensor to find metal on the ground. I think the logo was like a backyard, some guy searching something, some buried treasure or whatever. I thought it was a scam, downloaded it. It actually worked pretty well. So there's a magnetic field sensor. Now imagine imagine a contextual aware app where it warns you if there's too much magnetic field around you or something. There's a humidity sensor, which is again pretty neat. There's a temperature sensor telling you how hot it's getting, how cold it is. There's compass, obviously, and some Android phones have a fingerprint sensor. Again, keep in mind that air pressure, magnetic field, humidity, temperature, and fingerprints are not on all Android phones. Oh, that's one of the key things about iOS. iPhone as a platform is you have one hardware device. All these sensors are bound by hardware. So if Samsung, the Nexus 5 doesn't have a fingerprint sensor, but I think the Motorola X does, or one of those phones does. What do you do with all these sensors? There's so much data. If you think about it, 20 years ago, even 10 years ago, if you were to look at a person, you didn't have access to all this data about someone. You couldn't tell, hey, I know how fast you're moving. Mathematically, you can say, yeah, you're running pretty fast, but now with a sensor, an app can tell you, hey, you're running like 100 kilometers per hour, new world record. So imagine you were able to combine one of or more of these sensors to build your app. And then using that information, imagine you were able to personalize this data to a specific user. That's cool. Now, on the flip side, imagine if you were able to crowdsource this data. So take all these sensors and tell you, make an aggregated guess or make an aggregated, logical statement about a collection of people using your app. Now, what do I mean by that? Imagine if we go back to the temperature sensor and the humidity and the air pressure sensor, imagine a portable weather station, right? Imagine there were 100 people using your app, 1,000 people using your app, even 100,000 people using your app, right? They pull up your app and they get accurate weather information. At the same time, you're collecting atmospheric temperature and other types of data in that area right there, given to that phone. Upload that data to your server, and then you can make an aggregated guess. You can say, around Toronto, I have 100,000 users, and they're all reporting that the temperature is anywhere from 7 degrees to 9 degrees. So maybe you take an average of that. You can say that, you can actually get very specific. You can say, that's weird, the temperature at Times Square is 10 degrees hotter than the temperature just 3 kilometers away. I wonder why, right? Imagine you start plotting all this data. That's something that weather stations do not have access to. The weather stations aren't going around sticking weather sensors every 2 blocks, but a person is going every 2 blocks. You can actually, tell people that if you leave this, have this app, and then you can actually start plotting temperatures at an office. You can make up a crazy estimate like offices that are cold, users are much more likely to make phone calls, something ridiculous like that, because you have all this data now. So what's an actual real world use case that's happening right now? And that's Google Maps. If you were to drive somewhere right now, yesterday, for the past 2 days, I was in Boston, Buffalo, I mean, and we drove back, and Google Maps was a real big help because I was able to quickly see where traffic is. Now, where's this traffic data being aggregated from? Some of it definitely is coming from the cameras and the news stations reporting, but that's good. But there's something even more accurate where this data is coming from, and that's coming from your GPS and motion sensors. If you go into settings on Google Map on Android, it says report, I believe the phrase is like report my location and traffic data, live traffic data or something. And that's essentially what that's doing is if there's 100,000 people, or not even 100,000, say there's 100 people on the highway, right? 50 are 100 kilometers away. If those 50 suddenly come to a stop or will slow down a lot, the 50 people who are 100 kilometers behind them on their phone, and Google Maps is going to draw a red line. And the reason why, it makes an accurate estimated guess saying, hey, all these people have just stopped there. They're on a highway right now because I know via GPS, I think the highway is blocked. And now navigation will say, there is a 10-minute block out there. I'm going to reroute you. Do you want to reroute? That's really contextual, and that's based on crowdsourced data. So we can take an example, and I'm sure everyone's seen this. The red lines mean traffic is bad, green lines mean traffic is good. And really, all this is just based on cars moving and stopping, moving and stopping. It knows where there's a block. It knows where cars are moving freely. Obviously, this breaks if there's only one car out there who's just driving really fast, but it's crowdsourced data, right? Now, what you can also do with this data, like I was saying, is you can start making aggregated guesses over time. And Google Map does this. At the top right, top left actually, you'll see typical traffic, a radio button for it. If you were to click on typical traffic, you're able to choose anytime. I want to see, so say you go, all right, I'm planning a marathon, not a marathon, I'm planning a running event with my buddies on Thursday at 4 p.m. I want to see what the traffic's going to be. Click on Thursday, click on 4 p.m., and Google will give you, over all the data that they have, millions and millions of people who have driven cars around there. Google will give you a proper estimate. Now, this is Google with millions of people data, but you can still make that on your own small app. Because if you have 100 people using RAB, you can start making pretty good educational guesses because you have lots of good, accurate data on sensors. And so you come to me, or you go to your buddy on Stack Overflow or wherever, and you're like, wow, all these sensor stuff looks cool, but these are so hard to develop. Actually, they're not. Accessing sensor data is really easy. iPhone and Android all have really, really simple interfaces to build it. Literally, like if you're just beginning programming, you can learn a sensor development. Gone are the days where you're sitting there looking at port 001, dealing with binary data flowing in and messing around with electrons and all that stuff. Here, you're just like, it's just straightforward Java code or Objective-C code. Here's an example of a sensor changed event on Android. And all you're doing is, at the top, you register and you listen to all the sensor delays. You register and you get sensor data at a regular delay. You have to keep in mind the battery life. If you start grabbing motion sensor data instantaneously, that's going to drain the battery. But if you do a delay normal, you're going to get it every like 10 milliseconds, 100 milliseconds, something like that. Then on sensor change, you get this event fired back. iOS is the exactly the same. I believe you set up NS notification and you listen to all these events coming in, right? And here you're just checking this example. He's checking what rotation the device is in when it's in, moving in the accelerometer, all that fun stuff. So don't worry about it being too hard to develop. It's actually really, really straightforward. Okay, so what exists out there, and mainly this is not to tell you how everything's done already. It's actually to show, there's a permutation. There's all these sensors. If you put all these sensors together, you can start forming really unique apps. There's one great example that I discovered by accident, actually. It's called the Google Now Park Card. So Google Now, I'm sure everyone's used it, if not has heard about it, is the most contextual app out there. It knows based on where you are, what you're doing, it surfaces information, right? Sometimes better, even before you know you need it. I'm driving by and it says, hey, these are the movie times because I'm near a movie theater. Then I look at that and I'm like, oh, I didn't know X-Men was playing. Okay, so it really helps, it really, gets that information surfaced. But one neat feature is where you park your car last. And this is mind-blowing, right? If you look at this, I get a car, I don't have anything set up on my car, nothing at all. It doesn't even know the model of my car, right? And then all of a sudden it says, hey, 20 minutes ago you parked your car out here. And I'm sitting there wondering, how the heck did Google know that? And then you start thinking about all the sensors out there, and you go, hey, that's not actually that hard to implement. Literally, you can implement this for the hackathon, right? How does Google know where you park your car? It takes your GPS and motion sensor into account. It knows you were moving fast, so perhaps you're in a car. Then you come to a gradual stop, and after a bit, you start moving again, but this time, you're moving slowly, right? You're walking. You're not walking as fast as you were before. So what is the, good estimate, a good guess of what you were doing? You were driving a car and you parked it. I mean, another estimate would be you're driving a car, you jump out of it, but most people don't do that. So most people drive a car, park, walk out of it, right? Does it work 100% of the time? Not really. If you're in a bus and you get off and you start walking, sometimes they'll say this is where this is where you park your car. No, you didn't. You just got off a bus, but that's fine. Over time, it'll get better because it'll know. Actually, I'm not actually sure how I'll know if you're in a bus or not. But over time, data will get better. So how do you determine if your person was walking or running? Android specifically has an activity recognition API. It lets you find out if a person's walking, sitting, running. I think there's, I might not be sure, but I think there might be something for jumping. But then also lets you set up geofencing. So you can actually say, you can actually build something where it's like where you park your car in a shopping mall, right? And you can geo-fence out all the shopping centers out there, parking lots. So when when your phone crosses that line, you know, hey, I'm in a parking lot now. So start tracking movements and start tracking GPS and see where I parked my car last. You know, very, very context aware, and without a user doing anything and literally reading the user's mind. Here's another really great one. Oh, okay, and the link is missing. I'll put the link later in the thing. I don't know, it was supposed to be a cool image. But basically, Stanford guys at their university, they've developed a way to detect speech from a gyroscope. Now you're wondering, how the heck are they doing that? It's actually really clever and really smart. And this is one of the things that you should start thinking outside the box. Basically, when a person speaks, it emits sound waves, and this has an effect on the gyroscope. So if you were to go to Android, put your phone on the ground, leave it at rest, and start listening to gyroscopic events, and then you start talking, the vibrations are going to move the gyroscope sensor in the app, on the phone, and the app is going to report movements. So what Stanford did was they took all these movements and they ran it through machine learning. So they said, okay, whenever someone says hello, that has a specific wavelength. Whenever someone says hi, specific wavelength, a specific vibration, and specific values. Now, I oversimplified this, which is why I'm not at Stanford, because clearly there's a lot of math involved here. But again, it's not a tremendous amount of insanely crazy math. It's just thinking outside the box and taking the right context out there. Another great example that all you iPhone people have used every day now is a fingerprint sensor. Now, this fingerprint is uniquely tied to you, and what this lets you do is lets you log into your app, but then now lets you pay using your thumb. So that's really contextual. You know that, hey, I click my thumb, that's only me, only I can do it, unless someone cuts my thumb off and uses it. Hopefully that never happens to anyone. Another great one on the Android side is Google's face locking. And again, I have a funny story about this, but basically, if you take if you open up your Android phone, on most Android devices, it uses the front-facing camera, takes a picture of your face and compares it with what's in your local phone database, and says, hey, yeah, this is Faisal. Let him in. Now, this doesn't actually work 100% of the time. If you have a brother who looks a lot like you, and he grows a beard, and you have a slight beard, then the phone starts getting confused and lets him access all your personal data. So be wary of that. So thinking outside the box. Here's another really interesting one called Structure.io, and Structure.io has actually developed a hardware sensor. So this is an external sensor, nothing that exists on your phone right currently. However, it's an interesting challenge if you're able to do this with the current sensors that exist out there. But basically, if you point your phone with the sensor, take a picture of a device, run around the device in a circle, I think, it creates a 3D scan of that object, right? Very, very amazing, and that's a really powerful use of sensors out there. Now we're getting into some really crazy stuff, just at the end of the webinar, but here's something really interesting by Stanford again. Using your battery to track your location. So this is pretty interesting. Apparently, the further you are away from a cell tower, the more battery consumption your radio on your phone uses, right? So if you were to map out the distance between a cell tower and wherever a person is, and map out the battery usage over time, you can actually pretty accurately track where a person is without ever using GPS. Now that's a great example. If you use this for the good, not actually track a person, but a person gives consent. Hey, I want to track using this really cool method, and somehow pair this up with some actually good use case, good service. That's actually pretty neat. You don't need GPS. Your GPS doesn't have to be turned on. You can just have. It's the most safest app out there. It's not actually reading any sensor. It's just reading your battery life and using your battery life, determining where you are, right? And so there's articles, links at the bottom. The last link is a paper for if you want to read about how all the actual scientific and how they actually went about implementing it. Oh, okay, here's the gyroscope one. All right, so that was a gyroscope conversation. That's why the slide was switched around. So same thing. Stanford's doing a lot of crazy stuff using gyroscopes. They're able to listen to you speak. And of course, to end off the presentation on a great note, and of course there's Prism, right? I'm pretty sure everyone's heard of this, and this is like, from a development standpoint, this is one of the best examples of context and sensors, right? The NSA has various programs that they're collecting everything and anything, right? They're claiming they're collecting everything, right? This allows for some really, really neat applications and really scary. Okay, we're not talking about civil liberties or anything here. This is just from a pure technical standpoint, and thinking about how you can take this data, how you can take this technology and put it to good use, helping people out. Now, the NSA can take all this data that they have of you with the sensors. Imagine tracking yourself with the battery life, listening to your phone calls, with the gyroscope, and they can come up with a very accurate picture of you and a representation of who you are. Again, from a programming and development standpoint, that is pretty awesome. Imagine building that system where you're able to be intimately tied with a person's life. Now, imagine you say, okay, I'm not going to spy on people, but how do I actually make this into a good use case? Imagine your app actually tracked everything about a person's life, but kept it very, very private and exclusive to that person. That's actually a really great way. Imagine someone started using your app at age 20. At age 40 or age 50, they can look back through all their memories and all their everything. They can say, oh yeah, on September 30th, I was in Chicago, and I remember I remember this data dashboard saying it was 12 degrees out there, the air pressure was 100 whatever, and it was windy, and the local events were happening was at this. It's basically a snapshot of your life at that point. Now that is pretty powerful if that data is handled very carefully and very private, very encrypted just to you. That's actually a really great way. And looking back even a year from now, looking back and going, oh yeah, I was on vacation, here's some pictures, but then to recreate that memory in your mind, the temperature was 10 degrees, your battery, even something silly like your battery life was 10% at this moment. That is a pretty neat application of sensors and context. That is mind-blowing, right? So, closing thoughts. Sensors are everywhere. They're not just on your phone, but in your house also. You could actually look around. You could probably find a sensor in your house, and maybe there's an API for it, maybe there's not. But the Internet of Things is moving really fast, so you're able to buy light bulbs and stuff that have sensors in them, and you can say when you walk into a room, and if it's nighttime, change it to red or change it to blue, and all that fun stuff. Phones are everywhere, and they're a new limb for humans. So use this data and build something useful that helps humanity. It doesn't spy on people, doesn't do crazy, stupid things, but helps people out, right? Going back to the example about tracking your life, maybe it might be good for Alzheimer's patients to help with their memories. I have zero knowledge about how Alzheimer treatments work, but maybe that's an interesting use case. Who knows? And build something that makes your life better and the life of the user better. Thank you, and any questions? And that's my Twitter if you need to follow me. Send me an email. My email is faisalabid@gmail.com. So I'm pretty accessible.
Thank you very much, Faisal, for very cool webinar. So for all the viewers out there, if you have any questions, please just enter it in the question field underneath the broadcast there. But just to start things off, I have a couple questions and maybe a couple comments. I like how you mentioned Google Now is the contextual app, and I absolutely love Google Now. It tells me information that I didn't even think I wanted to know, but I do want to know.
Right.
So, like, where do you see Google Now in particular going in the future? Because like how much more information can Google Now take and actually make useful to me? Like, where do you see Google Now going?
I think over time Google's been slowly requesting more and more access to more of your data. Just the other day, if you actually go into Google and type in my receipts or my purchase receipts, it'll show you all your receipts, and those receipts will start showing up in Google Now, right? And so over time, I think there's a lot to be there. Like Google Now can probably have APIs that other third-party apps can put in, right? And they've started to do that. But imagine Google Now starts sourcing from your favorite apps. So Google Now starts showing your Evernote notes, because you were in this area, or it starts showing a specific movie trailer hooking into your movie trailer app because you're by a movie theater and that movie just made $100 million or something, right? So I think the possibilities are endless. It's just really about permutations. If you use that permutation formula and you stick in all the services out there, there's an infinite number of possibilities that Google Now or any other contextual app can start using.
Okay, so maybe extending from that, maybe this is a touchy subject, but what's Apple's take on Google Now, or what's their equivalent app going to be, or is there going to be an equivalent app?
I think I think Siri is their equivalent app. It's not as powerful, and it's not as used. Google Now is all about reading data. Where if I said Google Now, my phone turned on. It's all about reading data, and the processing at Siri is all about asking. But I think over time, all that everyone who's asking Siri information, Siri is learning. Apple came into this game, at a clean slate. Google had a search engine, so they know what people do. Apple has no idea, right? So I think over time, Siri's going to get better, and Microsoft has Cortana, which is apparently really good. I haven't checked it out, but I think all these services are, they're all just doing the same thing, but in a slightly different way. Some do it better. Google might just do it better right now. Over time, Apple might get better. Or surprisingly, Microsoft might get better because, Microsoft, it's funny to say, but Microsoft's becoming cool these days, right? They're doing lots of really fun, interesting stuff, and they're not keeping it closed. They're keeping it very open, very transparent. So I think Siri on Apple's, Cortana, and Microsoft.
Okay. Cool answer. So we actually got a question from Blake from the U.S. Faisal, you said learning to use APIs is very easy. You gave an example code. That was pretty cool. Can you recommend any good resources to get someone started?
Yeah. So here's a resource that I tell if you know how to program already, if you know how to develop, I say go to GitHub.com. In the search bar at the top, type in Android sensor or motion sensor Android, or anything related to what you're trying to learn, and you'll find insane amounts of sample code out there, right? That's personally how I learn. I just look at, literally I look at other people's code, copy and paste it, and modify it, right? That's how I learned how to use a sensor. So, Blake, the best thing to do, go to GitHub, start searching, looking at example projects. If you don't want to do that, if you want to, read the theory behind it, or, read steps on how to execute it, right now, Android documentation, if you go to developers.android.com or developer.iphone or apple.com, all of them have amazing documentation now. They're like no other better place than the official source now. So either one will do. I personally always turn to GitHub whenever I want to do something because someone almost always has done it, but not exactly the way you want it. So you can start, that as a base template, learn from it, and then implement it into your own code.
So we got a lot of resources. So maybe an extension from that question: how easy is it for me to access the information that's already on my phone?
From a user point of view or developer point of view?
From a user point of view.
Yeah, from a user point of view, it's not that easy, right? There's no apps. I mean, unless you go to the Play Store and there's someone made an app where you're able to see all your sensor data all the time. There's no, the OS, the default apps don't have anything built in where you can see your acceleration over time, your motion over time, right? Mm-hmm. So maybe that's an idea for someone. Maybe build a sensor dashboard and they can start tracking everything.
Or like a Google widget and have that on there.
Exactly, right? So definitely there's possibilities there.
Yeah, so it's very, very, very interesting talk. We don't have any more questions coming in at the moment, but you did leave your your contact details up there.
Yep.
I wanted to thank you for a really good, really cool, interesting webinar, and I just have a couple slides to actually wrap up this webinar. So thank you everyone for participating. Please complete our feedback survey, which I will be sending out in the near future. Our next Young Professionals webinar is actually going to be held in May 7th, 12 p.m. Eastern, and we're going to have a Personal Finance Webinar Series Part 2, where Maricel Ramos and Stacy here are going to be telling us some interesting tidbits on personal finance. Please check out our 2 career-based services for young professionals, the Mentor Center and the Resume Lab, where you can actually get tips and tricks on not only how to build a cool resume, but also interview tips. If you're interested in actually presenting a webinar, please shoot us an email or check us out online. And from that, I'd like to thank both Luca and Faisal for great webinars, and this webinar will be posted on our YouTube page in the next couple hours. But thank you both for a great webinar, and with that, I'm gonna sign off. Thank you very much, everyone.
Thank you.